Welcome to lesson 9.6 on solving rational equations and inequalities. Today we're going to solve rational equations and inequalities. A rational equation contains one or more rational expressions. To solve a rational equation, first multiply each side by the least common denominator to all of the denominators. Be sure to exclude any solutions that would produce a denominator of 0. So what we would look at is we would scan the denominators and we'd try to cancel denominators by multiplying by enough denominator to cancel every one. So a 10 will cancel a 10. A 10 is fine to multiply here. It won't make any cancellations in the denominator, but hey, we can multiply extra things. And a 10 will cancel with a 5 too. 10 divided by 5 is 2, and there's more than enough then when I multiply by 10. So when I multiply each term by 10, each part by 10, then I cancel that denominator and I'll cancel that denominator. We need a little bit more to multiply every term by in order to cancel this denominator. I really need the exact binomial x plus 1. So let's go ahead and multiply by 10 and by x plus 1. And that way there's more than enough to cancel each denominator, which is fine. We just can't have too little. We need to be sure that we do the cancellation. So there's the cancellation that I'm talking about. Perfect. Now what's left can multiply to the multiplier. So this is 9x plus 9 in this place for this first part. Plus sign can come down, and then we can cancel first, and then multiply to the value that I'm multiplying by. And I get 20. Equal sign comes down. Cancel first. 10 and 5 reduce because they're both monomials. 10 divided by 5 is 2. Then multiply all the rest. I'll multiply the monomials first. 2 times 2 is 4. Then distribute 4 to these other parts, and I get 4x plus 4. Now this, to me, looks so much simpler to work with than the original did. Okay, I love not seeing those binomials and denominator and the fractional 10 and 5 down there. Now there's no denominators. I feel free as a bird. Go ahead and subtract 4x. Combine like terms to 29, and I'm going to subtract 29 to move my constants to the right. 9x minus 4x is 5x. 4 minus 29 is negative 25. Divide by 5, x equals negative 5. All right, box it up, and now let's check. Okay, so I need to check my value here, negative 5, in the original. So everywhere there's an x, I'm going to replace it with negative 5. So 9 tenths plus 2 over negative 5 plus 1 is negative 4 equals 2 fifths. Okay. 9 tenths plus 2 over negative 4 is really saying 9 tenths minus 2 fourths. And so I can make both of these into tenths here, or maybe make all of it into 20ths. If I multiply the top and bottom by 2 and multiply this by 5, then if I multiply this by 4, okay. So 9 times 2 is 18 over 20 plus, I'm just going to make it a minus 10 over 20 equals 8 over 20. 18 minus 10 is 8. Good, they are equal. Okay, so then I have checked that x equals negative 5 works. Okay, great. Let's move on to number 4. Okay, so we're playing a cancel the denominators game. I have 2 different denominators here. They're both monomials, and I can normally get monomials to be canceled by one single monomial that I multiply to both of these, to all 3 of these parts, I mean. Okay, and so what's big enough to cancel a 5 and big enough to cancel a 2, and it can be more than big enough. It just can't be too small. To cancel a 5 and a 2, I can multiply that by their least common multiple, a 10. And it also needs an m so that m's cancel. 10m, and multiply by 10m. Okay, so first thing I like to do is reduce. M's cancel. 10 divided by 5 is 2, so I'm really multiplying by a 2. I'm going to distribute 2 to both terms. 2 times 3 is 6m. 2 times 2 is 4. Move over to the next part. What do we do first? Reduce. Take the m's, reduce. 10 divided by 2 is 5. Then what do we do? Distribute. 5 times 2m is 10m. 5 times negative 1 is negative 5. Over here, there's nothing to cancel by. That's all right. Then we just move over to multiplying. We get equals 40m. Okay. Take these terms then and combine. 6 and 10 is 16m. 4 minus 5 is negative 1 equals 40m. Okay, let's combine like terms. I'm going to move my m's to the left and my constants to the right. So minus 40m minus 40m plus 1 plus 1. So that's 24m, I'm sorry, negative 24m equals 1. So divide by negative 24, m equals negative 1 over 24. All right. And that will work out because I checked it previous year, but anyway, we can check it here. 3 times negative 1/24 plus 2 all over 5 times negative 1/24 plus 2 times negative 1/24 minus 1 all over 2 times negative 1/24 equals 4. So let's plug that in carefully. Over here, 3 times, you know what, I'm just going to store negative 1/24 as x. And then every time I hit x, it'll count. So really, I have that value x plus 2, all divided by 5x. And I get negative 9 there. And this is 2, this value I stored for x, minus 1, all divided by, oopsies, clear, all divided by 2x. And that's 13. Negative 9 and 13 is 4. Okay. Let's move on to number 5. Okay, I have 2 different denominators. One's a binomial, one's a monomial. Binomials and monomials cannot be canceled by the same things. Binomials need to cancel with an exact binomial. So we need to multiply both parts by x minus 1 to cancel the x minus 1. And we need to multiply both parts by 12 to cancel the 12. All right, let's cancel first, then distribute. This is 48. And then let's cancel first and distribute. This gets me x squared plus x. Now distribute the negative 1. Minus x minus 1. So I get 48 equals x squared minus 1. Move 48 over, I get x squared minus 49. And I know from doing these a lot of times I'm going to get plus or minus 7. Let's keep, actually, I should have moved things the other way. Add 1 over, I'm just going to switch this around now, x squared equals 49. Square root both sides, x equals plus or minus 7. Okay, we should check both values. 4 over 7 minus 1 equals 7 plus 1 over 12. 7 minus 1 is 6. 6 reduces to 2/3. 7 plus 1 is 8. 8/12 reduces to 2/3. Okay, so positive 7 works. Let's try negative 7. 4 over negative 7 minus 1. And then negative 7 plus 1 over 12. Negative 7 minus 1 is negative 8. 4 over negative 8 is the same as negative 1/2. Negative 7 plus 1 is negative 6 over 12, and that's the same as negative 1/2. So it works. All right, so both the plus and the minus version worked. Okay, let's try to head over to the next page to try some inequalities. Okay, now we're going to solve rational inequalities. We're going to do the following steps. We're going to first find common denominators. In this case, we would think that with 3, 5, and 3, that our common denominator has to be some multiple of 3 and 5, and it has to be the least common multiple. So it would be 15n, because 3 and 5 all have 15 in common. Then we would try to get that common denominator. So I'm going to multiply the top and bottom by 5 to get it to be 15n, and 5n needs a multiplier of 3 to be 15n, and 3 needs a multiplier of 5n to be 15n. So now I've got 5 times 2 is 10 over 15n, plus 4 times 3 is 12 over 15n, is less than or equal to 2 times 5 is 10n over 15n. Okay, next thing I want to do is get all the terms combined and to the left-hand side. So 10 and 12 is simply 22 over 15n, and I'm going to subtract 10n over 15n over. Okay. And it's still less than or equal to, and now it's 0 on that side because of me subtracting the 10n over 15n over. Okay, and now what I'd like to do is just write that as a single expression. Okay, and I personally, well, that's okay. I like to see it in standard form, the 10n first minus, and the 22 second, but I kind of like it in this order more just because the 10n's negative. Anyway, I'm just going to GCF the numerator, and I get 2, and I get 11 minus 5n all over 15n is greater than or equal to 0. Now what I'm going to do is I'm going to separate numerator and denominator. Okay, and then solve both. Okay, so I'm going to take the 2 parentheses 11 minus 5n equals 0 and the 15n equals 0. Okay, I'm going to divide by 15 and get n equals 0. I'm going to divide by 2 and just get rid of that term. Then I'm going to subtract 11, and I get negative 5n equals negative 11. When I divide by negative 5, I get n equals 2.2. So right now I have 0 and 2.2. Okay, next, I'm going to plot these on a number line, 0 and 2.2. I'm going to make vertical dashings, and I'm going to place the factored expressions on the left. Okay, so here's my factored expressions. The part right here, 11 minus 5n, and also the part right here, 15n from the denominator. Okay, and then I'm going to choose values from this region, from these 3 regions on the number line, and substitute them into these here and figure out if I get a positive or a negative when I substitute it in. So I substitute in negative 1. I get 11 minus 5 times negative 1, which is a positive, because 11 plus 6 is 17. No, sorry, 11 plus 5 is 16. Okay, and then 15 times negative 1 is a negative. Next, I need to choose something between 0 and 2.2. I think 1 is easy to work with. So when I substitute a 1 in here, 11 minus 5 times 1 is 5, so 11 minus 5 is 6, and that's positive. When I substituted 1 in here, 15 times 1 is 15, and that's positive. Now choose something above 2.2, like positive 3, let's say. So 11 minus 5 times 3, which is 15. 11 minus 15 is negative, and a 3 times 15 is positive. Okay, next thing I'd like you to do is to multiply the signs. Okay. Multiply the signs. Positive times a negative is a negative. Positive times a positive is a positive, and a negative times a positive is a negative. Okay. Now, I want to evaluate down here what's underneath this horizontal line here, and I want to see what's greater than or equal to, sorry, it should be less than or equal to, I don't know why the sign changed, what's less than or equal to 0, which is negatives. I also need one more thing. So this and this are my goal region. This is no-go. Okay. I also need one more thing. If I'm equal to 0 or just greater than 0, or if I'm equal to 2.2 or just greater than, or sorry, less than 0, or equal to 2.2 or just greater than 2.2. And so what I'll look at is if 0 itself can be a solution to this inequality. So I need to substitute 0 into the whole inequality. And in fact, dividing by 0 makes it not a solution. 2.2 goes in here. 2.2 times 5 is 11, and 11 minus 11 is 0, times 2 is 0, and 0 divided by anything is 0, and 0 is less than or equal to 0. So 2.2 is a borderline that works. Next thing I want to do is consider all solutions less than or equal to 0 because that negative satisfied the inequality, and then all solutions greater than or equal to 2.2 because that negative also satisfied the inequality, less than or equal to 0. Okay, so then I'm going to say negative infinity to 0 with a parenthesis because 0 cannot be a solution, and comma, or bracket 2.2 to infinity because everything 2.2 or greater worked. Okay. Let's go down to number 1 below. Okay, and let's do the same thing again. We got common factors to start. So I think my common denominator is 4x. So I'm going to multiply the top and bottom by 2. I'm going to multiply the top and bottom by 4 and the top and bottom by x. 2 times 3 is 6 over 4x. 2 times 4 is 8 over 4x. Is greater than x over 4x. Okay, 6 minus 8 is negative 2, and I'm going to subtract this x over as well. All over 4x is greater than 0. Okay, so now what I'd like to do is take the numerator, factor it, set it equal to 0. Okay. And then take the denominator, set it equal to 0, so I get negative 2 plus x is equal to 0, and also 4x is equal to 0. Okay, over here, divide by negative 1, subtract the 2, x equals negative 2. Okay, so I'm going to plot these two values on the number line. Negative 2 and 0. I can start really with the open circle and closed circle idea. So I'm going to start with plugging in negative 2 into this here. 3 divided by negative 2 times 2 is 3 over negative 4. So I'm starting with negative 3/4 minus 2 divided by negative 2 is negative 1. So it'd just be plus 1 is greater than 1/4. And I do get over here 1/4 then is greater than 1/4, and that's not true because it's not strictly greater, it's equal to. So then negative 2 does not work. So I'm going to put an open circle at negative 2, meaning when I substitute negative 2 into the original expression that it's not a solution. Now just for speed's sake, I'm actually going to substitute into the combined expression because it's a little bit shorter. Okay, so then 0 can go here, so negative 2 minus 0 is negative 2, but divide by 0, can't do it, so that's also going to be an open circle. Okay, now I can use dashed lines to break this up into regions, and I'm going to say that I'm going to put negative 2 plus x here, and I'm going to put 4x here, and then I'm going to break this into regions. So anything less than negative 3. So 2 minus 3 is negative 1, and negative negative 1 is a positive, and 4 times negative 3 is negative 12, so it's a negative. Anything between negative 2 and 0, like negative 1. 2 minus 1 is 1, and that negative is negative. Okay, and 4 times negative 1 is a negative. And then over here, anything bigger than this, like a positive. 2 plus 1 is 3, and negative that is a negative. And 4 times 1 is 4, which is a positive. Okay, now multiply vertically. Positive times a negative is a negative. Negative times a negative is a positive. Negative times a positive is a negative. All right, so you have these three regions, negative, positive, negative. All right, now let's figure out what the goal of the inequality was. It was everything greater than 0, so you want this region here. So everything from negative 2 to 0 is your goal region. Great. Okay, moving on to number 2. So we really wish to take 2p, 5p, and 3 and get a like denominator. That like denominator would be 30p. So we need to multiply the top and bottom by enough to get it to be 30. So 2 times 15 is 30, 6 times 5 is 30, and 10 times 3 is 30, and multiply the top by the same amount. Okay, so then we get 15 over 30p plus 6 times 4 is 24 over 30p is greater than 20p over 30p. Get all the terms to the left and combine like terms. 15 and 24 is 39, so 39, and then subtract the 20p over. All over 30p is greater than 0. Next thing we want to do is take the numerator and the denominator and separate them, factor them, solve them. So I'm going to take 39 minus 20p equals 0 and solve it. Take 39 over and divide by negative 20. And I get 1.95. And take 30p, set it equal to 0, and solve p equals 0. Take these two values, put them on a number line, 0 and 1.95. Make dashed lines working their way up, and take those expressions and put them off to the side here. Okay, over here I'm just going to put 30p, and over here where I have more space, I'll put 39 minus 20p. Okay, so with that then, we're going to substitute in like negative 1. 30 times negative 1 is negative 30, so it's going to be a negative there. And negative 1 times negative 20 will be positive 20, so this will be a positive. Let's plug in positive 1. 1 times 30 is positive 30, and 1 times 20 is 20, and 39 minus 20 is positive 19. Let's plug in something like 2. 30 times 2 is 60, that's positive. And 39 minus 40, which is 20 times 2, 39 minus 40 is negative. Okay, now let's multiply vertically. Negative times a positive is a negative. Positive positive gets us a positive. Positive negative gets us a negative. And let's also test the boundary values themselves, 0 and 1.95. I'm going to plug them into this expression where I got it greater than 0. So 39 minus 0 is 39, but divided by 30 times 0 is 0. Anything divided by 0 is undefined, and so that cannot be a solution. Let's try 1.95. 39 minus 20 times 1.95 is 0, and 0 divided by anything is 0, and 0 is not greater than 0 though, so that's going to be an open circle at 1.95. Okay, also we're looking for greater than 0, so we're looking for anything from 0 to 1.95, because that's where we have this positive sign from our truth table. Okay, great. So parentheses 0 to 1.95 parentheses. Thank you for joining me.